Is the universe expansion just a myth? A new study has turned upside down the model of the structure of our world. The authors of a new, potentially controversial study suggest that the expansion of the universe may be an illusion. This reimaging of the cosmos solves the mystery of dark energy and dark matter, which scientists believe make up about 95% of all energy and matter in the universe, but remain shrouded in mystery. The novel new approach is detailed in an article published in the journal Classical and Quantum Gravity by University of Geneva professor of theoretical physics Lucas Lombrisiere. What is the expansion of the universe? According to the generally accepted theory, the universe was born with the Big Bang and looked like a very hot and dense point. After unimaginably small fractions of a fraction of a second, the expansion or inflation of the universe began. Space itself expanded faster than the speed of light. During this period, the universe has grown in size at least 90 times. This is the theory, of course. After inflation, the growth of the universe continued, but at a slower pace. According to NASA, and as space expanded, it cooled and matter formed. A second after the Big Bang, it was filled with neutrons, protons, electrons, anti-electrons, photons, and neutrinos. About 380,000 years after the Big Bang, matter cooled enough to form atoms in an era of recombination, resulting in a transparent electrically neutral gas. However, after that moment, the universe plunged into darkness, since neither stars nor any other bright objects had yet formed. About 400 million years later, the universe began to emerge from a cosmic dark ages into the era of reionization. During this time of more than 500 million years, enough clumps of gas collapsed to form the first stars and galaxies, whose energetic ultraviolet light ionized and destroyed most of the neutral hydrogen. Although the expansion of the universe gradually slowed down as matter was attracted to each other under the influence of gravity, about 5 or 6 billion years after the Big Bang, according to NASA, a mysterious force, dark energy, began to accelerate the expansion of the universe. It's believed that this process continues today. Evidence for expansion and the cosmological constant. Scientists know that the universe is expanding due to redshift, the stretching of the wavelength of light towards the redder end of the spectrum. As the object emitted, it moves away from us. Distant galaxies have a greater redshift than those closest to Earth. This suggests that these galaxies are moving further and further away from us. More recently, scientists have found evidence that the expansion of the universe is not fixed, but is actually accelerating. There is a term for this phenomenon known as the cosmological constant, or lambda. What is the problem? The cosmological constant has been a headache for cosmologists because the particle physics predictions for its value differ from actual observations by 120 orders of magnitude. Therefore, the cosmological constant is called the worst prediction in the history of physics. Cosmologists often try to resolve the discrepancy between different lambda values by proposing new particles or physical forces, but the authors of the new study solved this problem by rethinking the existing versions. What does the new study suggest? In the mathematical interpretation of Lombrisiere, the universe is not expanding, but is flat and static, as Einstein once believed. The observer effects the indicate expansion can be explained by the evolution of the masses of particles such as protons and electrons over time. In this interpretation, particles arise from the field that permeates space-time. The cosmological constant is determined by the mass of the field. Since this field fluctuates, the masses of the particles generated by it behave in the same way. The cosmological constant still changes with time, but in this model, this process is due to the change in the mass of particles over time and not to the expansion of the universe. Field fluctuations lead to larger redshifts in distant clusters of galaxies than traditional cosmological models predict. Thus, the cosmological constant remains true to the model's predictions. Dark universe recipe. The new Lombrizier structure also solves some other pressing problems in cosmology, including the nature of dark matter. This invisible material outnumbers ordinary particles of matter by a ratio of 5 to 1, but remains incomprehensible because it does not interact with light. The physicists suggest that field fluctuations could also behave like an axion field, and at the same time, axions are hypothetical particles that are considered one of the proposed candidates for the role of dark matter. So as you can understand, this is all theoretical. These fluctuations could also do away with the dark energy, a hypothetical force that is stretching the fabric of space and thus pulling galaxies apart faster and faster. In the new model, the effect of dark energy will be explained by the masses of particles which at later times in the universe choose a different evolutionary path. And this is by Solask. This is all, of course, theory and hypothetical. Please leave your comments and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.